Proxima Centauri is closer to us than any other star. Yet for most of human history, we never knew it was there. Right now, light from Proxima Centauri is reaching your eyes. Light that began its journey more than 4 years ago. A star so close, yet so alien, that it challenges everything we think we know about stars, planets, and life beyond Earth. What if I told you that our nearest stellar neighbor is unstable, violent, and capable of stripping planets bare, while at the same time hosting one of the most promising Earth-like worlds ever discovered? A world that could have liquid water. A world that could be habitable. A world that may already be dead. Tonight, we are traveling just over 4 light years away, to a star that burns quietly in the cosmic dark. A star that may decide the future of humanity. This is the story of Proxima Centauri. And once you understand what lies there, you may never look at the night sky the same way again. In this video, you will discover why Proxima Centauri escaped human detection for thousands of years, how a tiny red star became the most important target in modern astronomy, the violent nature of red dwarf stars, the shocking truth about Proxima b, the closest exoplanet to Earth, and why our nearest neighbor may be both humanity's greatest hope and its greatest warning. Welcome to Where the Light Ends, a place where space grows silent, light fades, and the universe begins to reveal its darkest secrets. For centuries, humanity believed it understood its cosmic neighborhood. We mapped the stars, we named constellations, we measured distances, and yet the closest star to our sun remained invisible to us, hidden in plain sight. Proxima Centauri was not discovered until 1915. Think about that for a moment. For all of human history, for all ancient civilizations, for every philosopher who ever looked at the night sky, the nearest star to Earth was completely unknown. The reason is simple and deeply unsettling. Proxima Centauri does not shine like other stars. It is a red dwarf, small, dim, and faint. So faint that it cannot be seen with the naked eye, even though it is closer to us than any other star system. Located just 4.24 light-years away, Proxima Centauri is part of the Alpha Centauri system, a triple star system composed of Alpha Centauri A, Alpha Centauri B, and Proxima Centauri itself. For a long time, astronomers believed Alpha Centauri A and B were the closest stars to Earth. They shine brightly, easily visible from the southern hemisphere. Proxima, however, lurked in the shadows. It was only through careful measurement of stellar motion that astronomer Robert Innes finally noticed something strange, a faint star moving through space in perfect alignment with Alpha Centauri. That star was Proxima, and its name says everything. Proxima, meaning the nearest. But proximity does not mean safety. Proxima Centauri is a red dwarf star, the most common type of star in the universe. Roughly 75% of all stars in the Milky Way are red dwarfs. They are small, typically 10 to 20% the mass of the Sun. They burn slowly. They live incredibly long lives, trillions of years. At first glance, this sounds perfect for life. A stable star, a long lifespan, time for evolution to work. But Proxima Centauri is not gentle. Despite its small size, it is extremely active. Red dwarfs are known for violent stellar behavior, massive flares, sudden bursts of radiation, and unpredictable magnetic storms. And Proxima is one of the worst offenders. Astronomers have observed Proxima Centauri releasing stellar flares hundreds of times more powerful than anything our sun produces. In 2016, scientists recorded a flare so intense that Proxima briefly became 10 times brighter than normal. Imagine standing on a planet orbiting that star. In one moment, calm twilight. In the next, the sky erupts with radiation strong enough to strip atmospheres and sterilize surfaces. This is not science fiction. This is physics. And yet, despite this violence, Proxima Centauri holds something extraordinary. It holds planets. For decades, astronomers suspected red dwarfs might host planetary systems, but it wasn't until modern detection methods, particularly the radial velocity method, that confirmation became possible. In 2016, scientists announced a discovery that shocked the world: Proxima Centauri b, an exoplanet roughly 1.3 times the mass of Earth, orbiting within the star's habitable zone. The habitable zone is the region around a star where temperatures allow liquid water to exist, and Proxima b sits right inside it. Suddenly, the closest star to Earth also hosted the closest potentially habitable planet ever discovered. Headlines exploded. This could be Earth's twin. This is humanity's next home. This changes everything. But as always, reality is more complicated. Proxima b orbits its star at a distance far closer than Earth orbits the Sun, completing a full orbit in just 11.2 Earth days. Why so close? Because Proxima Centauri is dim. To receive enough warmth, Proxima b must cling tightly to its star, dangerously close. This creates a deadly consequence: tidal locking. Proxima b is almost certainly tidally locked, meaning one side of the planet permanently faces the star, while the other remains in endless darkness. One hemisphere scorched by radiation, the other frozen in eternal night. Between them, perhaps, a narrow twilight band, a fragile region where temperatures might allow liquid water. But even that hope faces a terrifying obstacle: Proxima Centauri's flares. Every flare bombards Proxima b with X-rays and ultraviolet radiation. Over time, this radiation can erode atmospheres completely. Studies suggest that unless Proxima b has an extremely strong magnetic field, far stronger than Earth's, its atmosphere may have already been stripped away. No air, no oceans, no life, just a barren rock orbiting a violent red star. And yet, astronomers refuse to give up. Why? Because Proxima b represents something deeper. It represents proximity. For the first time in history, a potentially habitable world exists within realistic interstellar reach. At current technology levels, it would take tens of thousands of years to reach Proxima Centauri. But with theoretical propulsion systems, light sails, fusion drives, or antimatter engines, that journey could be shortened to decades or centuries. In fact, the Breakthrough Starshot initiative aims to send microscopic probes toward Proxima Centauri at 20% the speed of light. If successful, those probes could arrive within 20 years. For the first time, humanity is seriously planning to touch another star, and that star is Proxima Centauri. But before we dream of arrival, we must face a darker question. What if Proxima b is already dead? What if red dwarfs, despite their abundance, are cosmic traps, offering false hope while quietly destroying the worlds that orbit them? If that is true, then the universe may be filled with planets that look habitable, but never truly were. And that realization changes everything. Because if even our closest neighbor cannot support life, what does that say about our chances elsewhere? At first glance, red dwarf stars seem harmless. They are small, dim, quiet compared to massive blue giants or explosive supernova progenitors. But this is an illusion. In reality, red dwarfs are some of the most violent stars in the universe, and Proxima Centauri is among the most extreme. To understand why, we need to look inside the star itself. Proxima Centauri is only about 12% the mass of the Sun and roughly 14% its diameter, yet its internal structure is radically different. Unlike the Sun, which has distinct layers, a core, radiative zone, and convective zone, Proxima Centauri is fully convective. This means hot plasma constantly churns from the core to the surface and back again. That constant motion generates immense magnetic fields, and when magnetic fields twist, snap, and reconnect, stars explode. These explosions are known as stellar flares. On the Sun, flares are disruptive but manageable. On Proxima Centauri, they are catastrophic. Astronomers have observed Proxima releasing super flares, sudden eruptions that unleash massive amounts of X-ray and ultraviolet radiation. Some of these flares are estimated to be hundreds to thousands of times more energetic than the largest solar flares ever recorded. In 2019, one flare briefly increased Proxima's brightness by a factor of over 100 at certain wavelengths. If Earth were orbiting Proxima Centauri at the same distance as Proxima b, our planet would be unrecognizable. Oceans would boil away, DNA would be shredded, atmospheric chemistry would collapse. Life, as we understand it, would struggle to survive. And this is where the paradox begins, because Proxima b sits directly in the habitable zone, the region where liquid water could exist. But that zone is not safe. It is a radiation kill zone. Proxima b receives up to 400 times more X-ray radiation than Earth does from the sun. Over time, that radiation strips molecules from the atmosphere, one by one, allowing them to escape into space. Hydrogen escapes first, then oxygen, then everything else. What remains is a dry, airless world. Some scientists argue that Proxima b could protect itself. Perhaps it has an unusually strong magnetosphere. A magnetic shield could deflect charged particles and preserve an atmosphere. But there's a problem: tidal locking. Because Proxima b orbits so close to its star, gravitational forces likely slowed its rotation until one side permanently faced Proxima Centauri. This weakens the planet's internal dynamo, the very mechanism needed to generate a magnetic field. No rotation, no strong magnetosphere, no protection. This creates a haunting possibility. Proxima b may have once been habitable, and then slowly died. If life ever formed there, it may have been erased long before humans existed. But Proxima b is not alone. Astronomers have detected at least 2 additional planets in the Proxima system. Proxima Centauri c is a larger, colder world, likely a super-Earth or mini-Neptune, orbiting much farther from the star. It is not habitable, but its existence confirms something critical. Proxima Centauri has a complex planetary system, which raises an unsettling question. If red dwarfs are so hostile, why do they keep forming planets? Red dwarfs live extraordinarily long lives, trillions of years. Long after stars like our sun burn out, red dwarfs will still shine. This has led some scientists to argue that life around red dwarfs may emerge later, once stellar activity calms down. Proxima Centauri, however, complicates this theory. Despite being over 4 billion years old, it is still violently active. It never truly settles. Its flares may decrease slightly over time, but they never stop. This suggests that many red dwarf systems may remain dangerous indefinitely, and that realization reshapes our search for life. Because if 3 out of 4 stars in the galaxy are red dwarfs, and most of them are hostile, then the universe may be far quieter than we imagined. But Proxima Centauri doesn't just challenge biology, it challenges our understanding of habitability itself. For decades, scientists focused on the habitable zone, distance from a star. But Proxima teaches us that distance alone is meaningless. Stellar behavior matters, magnetic activity matters, radiation matters. A planet can sit in the perfect zone and still be lifeless. And yet, despite all this, Proxima b remains one of humanity's highest priorities, because proximity changes everything. Proxima Centauri is close enough that we can study it in unprecedented detail. We can analyze its light, its flares, its planetary transits. Future telescopes may even detect atmospheric signatures, traces of oxygen, carbon dioxide, or methane. And if we ever detect oxygen, that would be revolutionary. Because oxygen is hard to maintain without life. But here's the catch. On a planet bombarded by radiation, oxygen can be produced abiotically through the breakdown of water molecules, a false biosignature, a lie written in the sky. Proxima b may fool us, and that leads to a deeper, darker realization. What if many of the habitable worlds we detect are illusions? What if the galaxy is full of planets that look alive, but never were? Proxima Centauri may be teaching us humility. It may be warning us that life is rarer and more fragile than we want to believe. And still, Humanity watches, because Proxima is not just a star, it is a mirror. It reflects our hopes, our fears, and our desperation to not be alone. If life exists anywhere beyond Earth, we want it to be close, and Proxima Centauri is the closest place to look. For all of human history, the stars were unreachable. They were symbols, myths, lights in the sky. Proxima Centauri changed that. For the first time, humanity discovered a star close enough to feel attainable. At just 424 light-years away, Proxima Centauri sits on the edge of impossibility, far beyond our current reach, yet close enough to dream about seriously. But dreaming is not enough. To understand what it would take to reach Proxima Centauri, we must confront the brutal reality of space. Using conventional rockets, traveling to Proxima would take over 70,000 years. Civilizations would rise and fall. Languages would vanish. Humanity itself might not survive the journey. So scientists began thinking differently. What if we didn't send humans? What if we sent machines, tiny, fast, disposable messengers? This idea gave birth to one of the most ambitious projects in scientific history, Breakthrough Starshot. The goal is as radical as it is simple. Send ultralight probes, no bigger than a postage stamp, to Proxima Centauri at 20% the speed of light. At that speed, the journey would take just 20 years. No cryogenic sleep, no generation ships, no colonies, just speed. The probes, called star chips, would be attached to thin reflective sails. From Earth, powerful lasers would push these sails, accelerating the probes to relativistic velocities. If successful, humanity would receive its first close-up images of another star system within a single lifetime. But this plan comes with terrifying risks. At 20% the speed of light, even a grain of dust becomes lethal. A collision with a single particle could destroy a probe instantly. And then there's communication. Once a star chip reaches Proxima Centauri, it must send data back across 4 light-years of empty space, using almost no power. Even if everything works perfectly, the first images of Proxima b would arrive on Earth decades after launch. Delayed truth. And yet, humanity is willing to try. Because Proxima Centauri represents something more than a destination. It represents a threshold. Crossing it would mean we are no longer confined to one star. It would mark the beginning of an interstellar species. But before we celebrate, we must ask a darker question. What happens if we get there and find nothing? No atmosphere, no oceans, no signs of life. Just a silent, radiation-scorched world. Would that be a failure, or would it tell us something essential? Some scientists argue that Proxima b's true value is not life, but knowledge. If Proxima b is dead, then red dwarfs may be hostile to life everywhere. That would reshape our search for habitable worlds. It would tell us to look elsewhere, around stars more like our sun. But others believe Proxima Centauri may still surprise us. Life, if it exists there, may not live on the surface. It could exist underground, shielded from radiation by rock and ice. On Earth, life thrives deep beneath the surface, in caves, oceans, and volcanic vents. Why not on Proxima b? And then there is the most unsettling possibility of all. What if Proxima b once had life, and lost it? A fossil planet, a warning written in stone, a reminder that habitability is temporary and extinction is easy. If that is true, then Proxima b is not our future, it is our mirror, because Earth too depends on a star, and stars change. The sun will not always be stable. Its brightness will increase, its radiation will intensify. One day, Earth will no longer be habitable. Proxima Centauri forces us to confront a truth we often ignore. Planets are fragile, civilizations even more so. This is why Proxima Centauri matters, even if it holds no life. It tells us that survival may require movement, expansion, redundancy, more than one world. But there is another layer to this story, one rarely discussed: ethics. If we one day develop the ability to reach Proxima b with humans, should we go? If life exists there, even microbial, do we have the right to touch it, to change it, to claim it? Human history offers a grim warning. Every time we reached a new land, something was lost. Cultures vanished, ecosystems collapsed, extinction followed discovery. Would space be any different? Or would we carry our old mistakes into the stars? Some argue that if Proxima b is lifeless, it is fair game, a backup world, a second Earth. But others believe that even lifeless worlds have value as natural archives of cosmic history. Proxima Centauri forces us to decide who we are before we leave Earth: explorers, colonizers, observers, or something entirely new. And perhaps the most haunting thought of all: what if Proxima Centauri is watching us too, not with eyes, but with time? Because right now, light from Earth is traveling outward. Radio signals, television broadcasts, radar echoes, our presence is already written into the void. In 4 years, Proxima Centauri will receive our earliest messages. If something exists there, it already knows we are here. And maybe that's why Proxima Centauri feels so important. It is not just close in distance, it is close in consequence. What we choose to do next, whether we reach for the stars or remain confined to one fragile world, may define the rest of our species' existence. Proxima Centauri stands at the edge of that decision. A silent star, a violent sun, a possible future, waiting. When I started researching Proxima Centauri, I expected answers. What I found instead were questions, heavier ones. We like to imagine the universe as full of life, full of neighbors, full of second chances. Proxima Centauri sits so close to us that it almost feels like an invitation, like the universe saying, "Here, try again." But the more I learned, the more uncomfortable that idea became. Proxima b may look like hope on a chart, a planet in the habitable zone, a world just a few light years away. Yet in reality, it may be a reminder, not of our future, but of our vulnerability. A planet can have the right distance, the right mass, even the right chemistry, and still lose everything: atmosphere, water, time. That thought changes how I look at Earth. Because Earth isn't special because it exists. It's special because it survived. Proxima Centauri doesn't promise us a new home. It warns us how easily one can be lost. And maybe that's the point. Maybe the universe isn't silent because life is rare. Maybe it's silent because life is fragile. Proxima Centauri is close enough to reach, but far enough to remind us that there are no guarantees beyond this world. If we ever go there, I don't think we'll find salvation. I think we'll find perspective. And sometimes, that's more important. This is where the light ends. Thank you for watching, and remember, some questions are meant to remain unanswered.